All right, so let's practice some verifying identities. So if you see the left side of my equation is definitely more complicated than the right-hand side. And I have a set of parentheses. So I'm going to start by multiplying through and distributing the cosine. And I'm not going to touch the right-hand side. Every step that you take, you always have to write the right-hand side, and you're just showing how you're changing the left-hand side. So the next thing that I'm going to do, I am going to notice that tangent, whoops, I'm writing it again. Tangent is really the sine of theta over the cosine of theta. And cotangent is really the cosine of theta over sine of theta, not changing the right-hand side. In the first part, the cosines will cross off. I have sine of theta plus cosine squared of theta over sine of theta. I'm going to move this down. There we go. Okay, so now you see that we have two fractions, and ideally you want to get them into one fraction. So I'm going to multiply, the denominator is sine, so I'm going to multiply the first fraction by that, this is not writing well, by the common denominator so that you can end up, so we have sine squared of theta over sine of theta plus cosine squared of theta over sine of theta equals cosecant of theta. Let's move this down again. Usually you do need a lot of room to do some identities. So we have, if we add them together, sine squared of theta plus cosine squared of theta over sine of theta. And we know that the sine squared of theta plus cosine squared of theta is 1. And that gives us 1 over sine, which happens to be cosecant. So your last step should be the exact same thing written on both sides of an equation. Okay, we're going to do a couple of these. They are oftentimes what people don't like the most. So I am looking at this first problem, and the left-hand side is definitely more complicated. And I notice that I have cosecant of theta. And cosecant of theta is, whoops, 1 over the sine of theta. So I'm going to make that change. And what I have here is sine over sine, so I end up with 1 minus cosine squared of theta equals sine squared of theta. Now, in order to prove identities, you have to take the identity in the form it is written in. You can't manipulate it. So what I know in trigonometry, that 1 is the sine squared, same thing as the sine squared of theta plus cosine squared of theta. That substitution went in for the 1. That's the identity that I used. If I look at the rest of the problem that I have and write it down as is, I'll notice that cosine, oh, that was a squared of theta minus cosine squared of theta are going to add to 0, so I end up with just sine squared of theta equals sine squared of theta, and we are done.